VPC is a component of which AWS service?
Networking.
B.
C.
C. VPC allows you to.
Option B.
Okay, we're going to talk about a custom VPC. Let me get some water, guys. 1 second. Get some water, please. So a default VPC comes with every account pre-configured. So, yeah, right. Your accounts came with a VPC, right? Already involved in there, right? That you did not create. And it comes with um and it comes with a default VPC that you yourself configured. So you don't have to worry about it. Um You just use it as it is, right? It comes with multiple availability zones. As you can see the diagram here, this is the AWS cloud. Inside of the AWS cloud, you have, let me see, we're going to annotate, uh, draw, highlighter. Inside of the AWS, this is the AWS cloud, what you see here in this box, right? This square box. And then this is the VPC inside of your account, right? And then inside your VPC, you have availability zone. So this is US 1A, and then you can have US 1B, right? You can also have US 1C, US 1D, US 1E, and US 1F in North Virginia, which has 6 availability zones. US East 2 has 3 availability zones. Um, homework, homework. Kwasi, write this down and share with the group. Homework. Find out how many regions exist in the world and how many availability zones are in each of those regions. That's the homework. I think I gave you some homework in the beginning of class, but since it was last year, let's do it again. How many regions exist in the whole world and how many availability zones exist in each of those regions? Please submit this homework by email. It's due on Monday by 7 p.m. Everybody, please. Let's know how many availability zones are in each region and the name of each availability zone as well. So North Virginia is the English name, US East dash one is their API name, is their code name for the region, right? Then you also have the airport code. Also get the airport code, right? The airport code is for example, North Virginia is called IAD. They name every region based on the airport code. So for example, if there was a region in Dallas, it'd be DFW. If there's a region, the region is in US East, in US West 1. The region in US West 1 is called SFO because US West 1 is in San Francisco and the airport in San Francisco is called SFO. Okay? Now you don't have to know the airport codes, but if you work at AWS, you have to know them because in AWS, internally we call the regions IAD. We call it SFO. We'll call it Oregon, right? Or we'll call it DRO. So we'll call it based on the like LHR, London Heathrow Airport is the region called in London. So that's how we call this um like Charles de Gaulle in Paris is CDO, something like that, right? So that's how we call those regions. So this is the default VPC. Any questions on default VPC? It comes to every account by default. Any questions there? No. Okay. Cool. So this is the custom VPC. And in the custom VPC, um, you have your AWS account, right? This is this bigger square out here, right? And you can see that in this AWS account, you have a VPC inside of here, right? This is VPC, right? And this is the default VPC URL, 172.31.0.0/16. So 16 gives you 65,436 private IP addresses, right? They're private by default is private because you don't have an internet gateway. Once you attach an internet gateway to that VPC, then that VPC can become public. If you attach an internet gateway to your VPC becomes public. You can see here, this route 0 to 0 to 0 is an internet gateway. So this means that any connection on the internet can connect to your VPC. That's the route right there, right? And this is the IGW, Internet Gateway ID. This is it right there. And the route, the destination for the local route, that pretty much this right here, 172.361.16, it takes this right here. So your subnets in that VPC will take this form, right? That's why you see every private IP address in here is like this, right? Because of this is what? This is the first what? What is this IP address? What is this IP address, guys? Come on. This is the first subnet in the IP, right? This is the first subnet, 172.31.0.0/20. How much does slash 20 give you? How many IP addresses? Slash 20 gives you how many IP addresses? Hello? Can you guys hear me online? Hello? Is anybody there?
Yes, yes, yes.
Use your calculator, right? You can use the calculator, guys. Slash 20 gives you how many IP addresses? Or you have to know, you have to cram it. You have to just know. This is stuff that you have to cram. This one, I'll not lie to you. You have to know it. Slash 16 gives you 65,500 IP addresses. Slash 20 gives you happy in the subnet, yeah, your default subnet slash 20, 172.31.0.0/20 gives you how many IP addresses? Man, you guys have not practiced since Monday? I thought you guys were studying every day. Did anybody study today?
130.
What?
130. Okay.
Hey, guys, let's stop. Let's stop what we're doing. This calculator is a cider block calculator. This is called a cider block. Whenever you see an IP address that has a slash, it's called a block. This is a cider block. CIDR stands for Classless Interdomain Routing Notation. It's a compact method for specifying IP address ranges and network masks. It is widely used in network configuration and management. An IP address consists of 4 octets. This is the 4 octets. This is the 4 octet, each containing 8 bits that represent values from 0 to 255. So each of these values contain 8 bits. 8 bits, 8 bits, 8 bits, 8 bits. That's why we can go 8 up, like 8, 8, 8, 8. So 0, 8, 16, 24, 32. Just like that's how we're trying to go 8 because it contains 8 bits. And then the last IP address in each of these is 255. You cannot go above 255. In standard notation, a forward slash like this, followed by a number, indicates the length of the network prefix in bits. This right here. So this 28 indicates the length. So that it's just 28 gives you 16 IPs. This prefix length determines the network mask. So this is the network mask. This is the network mask. This /28 is a network mask. It's called a network mask. This prefix determines the network mask and the number of available host addresses within the specified IP range. This calculator helps you visualize and understand these other blocks, making network planning and configuration easy. Whenever they give you an IP address, you come in here, you plug in the numbers and calculate how many IPs it will give you. 172.31.0.0/16 is the default VPC. Every default VPC in AWS, this is it. Every default VPC in every account in AWS, this is the IP address range. Because it has a /16, it makes it a range. When you move the /16 and just this is an IP address, but because of the /16, it's a range. Because there are 65,506 IPs in there. Amazon reserves 5 IP addresses. Tolu, Amazon reserves 5 IP addresses for its use. Amazon reserves the first 4 IPs and the last IP address. AWS reserves IPs. Tolu, Amazon reserves 5 IP addresses. The first 4 IP addresses and the last IP address, because they do not support broadcasting. Broadcasting is the last IP address, the one that ends with 255. That's what's used for broadcasting. This is what radio stations use, because radio stations are broadcasting, or TV stations use this for broadcasting. This is the last IP address in a range that sends traffic out. So they use it for broadcasting. Amazon reserves the first 4 IP addresses, the 0, 1, 2, and 3. Tolu, Amazon reserves the first 4 IP addresses, the 0, 1, 2, and 3, and the last IP. So out of the 530, 65,536, 65,031 are usable IP addresses. This is the last usable IP, 172.3.1.255.254. Why 254 here? Because what? 255 is reserved. So the last usable IP is 254. And this is the broadcast IP that Amazon has reserved. And this is the first IP address. And this is the first usable IP, but this is not an AWS calculator. This is a public calculator. Any questions on this? Is it clear now?
Yes.
So with the VPC of the /16, you can create larger subnets because you have 65,000 IPs. If you change it to a /20, you only have 4,000 IPs. Can you still create larger subnets? No, because you only have 4,096 IPs and 4,091 usable IPs. You have gone from 65,000 to 4,000. So your number of IPs have really, really reduced. That is the reason why the other day we were creating IPs, when we were creating subnets using the /20, it was failing because we couldn't create large subnets. What is a large subnet? A large subnet is when you go from creating, this is a large subnet. Where is that page I did last week? I'll just do a new one. This is a large subnet. When you have a VPC of 172.31.0.0/16, this is your VPC, right? And then in this VPC, this is your first subnet, 172.31.0.0/20. It gives you 4,096 IPs, in which 4,091 usable IPs. In AWS, in Azure, they have their own reservations as well. Another subnet, I'm going to just stick to 2 subnets for time purposes. Or maybe 3, so the point can go across. We're creating larger subnets. So what will be the next number? What will be the next number for larger subnets?
16.
Thank you. 16.0/20. This will also give you 4,000 IPs. Of which 4,091 usable IPs. Right? In AWS. Final subnet. If I'm creating another subnet, like this. One 172.31. What's the next number? If I'm doing a larger subnet, what's the next number?
32.
32. Sorry, here it's supposed to be a 16.0. 32.0/20. Same thing, right? Same thing. So this /16 allows you to have 4,000 IPs in each of your subnets. So you can keep going until you have 4,000. When you add all 4,000, 4,000, 4,000, you will end up with what? 65,536, of which 65,531 are usable in AWS. Is this clear for larger subnets and a VPC? Is this clear?
Debo, sorry.
Mm-hmm.
If the IP in the VPC is, for example, 172.31.0.0/8. So if I want to get the larger subnet, the first one will be 172.31.0.0.
Sorry. Let me not get. Well, I haven't talked about /8. Guys, let's just let me cut to there. This IP address 10.0.0.0/8 is only on premise. It's only on premise. Let me shout it again. A /8 is only on premise, so do not think about any /8. Because a /8 is on premise, a /8 maps, this is on premise. Hold your thought for a second. I know what you want to ask. This is an on-premise network, only on-premise. This on-premise, I've never seen a /16. And before cloud came, there was on-premise. That means data centers, physical data centers, physical location in Dallas, in Miami, physical servers. And then when cloud was created, they say, oh, we cannot use a /8 anymore in the cloud because it already exists. So let's extend our network from a /8, you guessed it, to a /16 in the cloud. /16. That's where /16 came about. And then, because this was the first IP address that Amazon reserved and Amazon kept for its VPCs, it kept on going bigger and bigger and bigger, and people kept on using it. So Amazon went and bought another set of IP address range, 172.31.0.0/16, and kept it as the default VPC for all accounts. And then customers who don't want small operations, don't want to do big things, they went and bought another one 192.168.0.0/16 for small businesses. And so Amazon named this IP address class A. And they named this one class B. And they named this one class C. So based on your type of business that you run, if you're an enterprise business or small company, you're going to use the class C. Geico and State Farm and Liberty Mutual Insurance, they all use class A because they're coming from on-premise. They already have a /8. So they want to extend their network, expand the network into the cloud. So they go from a /8 to a /16. There's nothing like a /8 in AWS. There's nothing below a /16 in AWS or in any cloud provider, anywhere. Oracle, AWS, Google, anywhere. You can Google me, quote me anywhere, anytime. It's a /16. It begins in a /16 going up. You can have a /16 VPC. You can have a /20 VPC. The higher you go, the lesser and lesser IP addresses you get. If you go to 24, you have 256. If you go to a /28, you have 16. You will never see a /16 VPC or a /24 VPC because it's only 200 IPs. You can see a /24 subnet. I don't even think you'll see it. You can see a /25 subnet for some small marketing applications and HR department applications. You can see a /25 subnet, but that's the maximum you see. Anything from here, 26, is the direct IP addresses. 64 is small. 27, 32, 28, 16, 29, 8 IP addresses. 30, 4, 31, 2 IPs. 32, this. 33, nothing. There's no 33. 34, you cannot type it in. 35, it's not going. The maximum is 32, /32. Okay, now ask your question.
I think you've answered it, showing me everything like that.
You see where I'm coming from? I know what you guys know, right? Guys, this thing I'm teaching you can make you, how can I put it? Once you know VPC so well, the company cannot get rid of you. Let me say it again. Once you know VPC very well, you are unfireable. Daniel, one of my ex-students, knows this stuff so well. He's made so many mistakes in the company. They fired him. After 2 weeks, they brought him back because he built their VPC with Terraform. And he didn't share the knowledge with nobody else. So he's the only one who knows the infrastructure. You can hold a company hostage with information that you have about a company. You're the only one that know that stuff. They cannot let you go. They don't have a choice to keep you. There's another guy that I work with as well. He built the company from the ground up. He doesn't have a good character. They cannot find. He's there. He's not sharing. Everything that you want to do has to go through him. So I left the company when they continue. Anyway, that's a different story. So this is it. This IP address that you see here is the default VPC for every account. Every account has that. If you look in your account, your default VPC is a 172.31.0.0/16. And guys, it's only 3 numbers. This is the default VPC. That's it. That's it. You can see that I'm not using the default VPC. I'm using the class A in my account. I have some applications around on my account. I'm using this class A. This is a class B. I'm using a really large one. So if I have my on-premise environment that has a /8, I'm extending my network into this from on-premise. So do we understand this calculator now? And do we understand how to use it? Yes?
Yes.
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 Okay. So a VPC like that, you see, the CIDR block for a default VPC is always a /16, right? Tolo is always a /16. For example, 172.3.1 is a /16. So this is a default VPC. It gives you the number of IPs. And then you have a private IP address. So my question in the beginning before all this rigmarole was, so if your subnet is 172.31.16.0, it's your second subnet, and your first subnet, which is an availability zone, your subnet is pretty much another space within your VPC. So it's like in your house, right? You have the internet in your house, you have the Wi-Fi in your house, and they decide to create a small intranet within your house, only a network within your office. So you have a network in your office, in your bedroom, all right, in those areas, a small area right there, right? That's what an intranet is. Okay. Um, okay, cool. So if your first subnet is this is your subnet, right? So your subnet is 172.3.1.0.0/20. It gives you 4,000 IPs. Your private IP will always take the form of the subnet. Let me say it again. The private IP will always take the form of the subnet. So this IP address 172.3.1.0.5. What is this IP address? What would you call this IP address? Based on everything we've just talked about.
First usable IP address.
The first usable IP address in AWS, because the first one is what? The first IP address will be what? 172.3.1.0.0. The second IP will be 172.3.1.0.0.1. The second IP will be 172.3.1.0.2. Right? Let me go back to AWS. This is the first IP. So 0 is 1. This is the second IP. This is the third IP. And this is the fourth IP. Right here. And then this is the last IP address. So this is the first usable IP because it's a .05. Okay? And then same thing here. If your subnet is 172.3.1.16.0/20, that's your subnet. The IP address will take the form of a subnet. So that's why the first IP here is 172.3.1.16.5. It takes the form. If you have another subnet, that is 172.3.1.32.0/20, the first IP will be 172.3.1.32.5. Do you understand how the private IPs are generated now? The private IPs are generated based on the subnet form. Do you understand that piece? Or should I go over it again? Let me know. I'll go over it again. It may take us 2 weeks just to learn VPC, eh? I don't mind. I have the time. We'll have on the March. Is you understand? Should I go over it again? How are IP address generated? How are your private IP address generated? Should we go over it again?
Yes.
Okay, that was easy. Okay. Hmm. Okay.
Or Debo, sorry, can I have a moment? I want to try and explain it, and I want you to correct me if I'm putting it in the wrong way. Because it's a private IP and it exists within the subnet, so it's going to take the form of the subnet itself, the subnet IP address. But for the public IP, that
Private,
goes
no, no,
outside
no,
the.
stop. We haven't gone to the public IP. I want to just explain how are these private IPs generated? That's all my question I asked.
Okay. So my understanding is it will always take the form of the default subnet because it also exists inside the subnet.
Mhm.
Um,
So, for example, if the subnet is 172,
723100.
no, 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 no. Say it again, try again.
For example, if the subnet is 172.31.0.0 forward slash 20 or
Mhm,
slash 20,
mhm.
the private IP will be 172.31.0.5,
Which is
being
what?
the first usable IP address in the subnet, in the AWS IP address.
Thank you. If your subnet is 172, guys, listen to me. Anyone can answer this question. If your subnet is 172.31.48.0 slash 20, what would be your first usable IP in AWS? Private IP in AWS.
It will be 172.31.48.5.
Thank you. You have understood how private IPs are generated. Thank you so much. So that is how private IPs are generated. If you choose a .10.0.0.0/16 VPC, you have to create a 10.0.0.0/20 subnet. And then your private IP address will be 10.0.0.5. That will be the first IP. That's how your private IPs are generated. So when you create an EC2 instance in the subnet, all instances or resources are created within the subnet. When you create your EC2 instance, which is a server in the subnet, by default, that server comes up with a random private IP address. It's not normally the first IP address that it takes. It takes a random IP address, a random number. That's the private IP address. That's what I generated. Now, for the every EC2 instance by default has a private IP address. By default, every EC2 instance has a default private IP address. Now, when you decide to attach an internet gateway to your VPC, how do you attach an internet gateway to your VPC? You attach it to the router, to the router. When you do that, when you do that, um, what happens is it leads to it leads to having when you attach your internet gateway to your VPC to the router, it makes the VPC become public. How do you attach it? You attach an internet gateway to your router by adding these routes 0.0.0.0/0 to your VPC. 0.0.0.0/0 is an IP address range that says any IP anywhere, anytime. That's why when you put this in your security group, you can connect to an EC2 instance anywhere, anytime. It doesn't require any specific IP address. So this means open to the world. This IP address means the instance is open. Anyone can connect to it as long as they have it. So this internet gateway makes this VPC become public. When the VPC become public, by default, the EC2 instance would acquire an, an IP address because the EC2 instance is public, meaning that it has to connect to the internet. As you guys know, anytime you connect to the internet, you must get a logical address. An IP address is a logical address. So when you have to connect to the internet, you need to have a public IP address, a logical address on the internet. And as such, the public IP address will be based off of the location of the VPC or the area. Since it's the internet, based on the zip code of that area, the EC2 instance will acquire, or the router will acquire an IP address in that physical location. In US East 1, North Virginia, this address, the public IP address given to the EC2 instance will be based on North Virginia in that zip code. That's why it doesn't take the form of the subnet. It doesn't take the form of the subnet. It acquires an IP address based on the location on the internet. So if you create a server in North Virginia and you use this VPC, your private IP will look like this. Whereas your IP address, which is public because it's the internet, it will take a random IP address of that location. You see here, it takes 203.0.113.17. And then here it takes 203.0.113.23. What happened to the .18? Someone else has acquired it. Remember, this is the internet. It's free for all. Everyone's in the internet. So this instance is creating, it takes 17. Don't expect the next institute instance to take .18 because some other people are in that area using the internet. It takes a split second. Every second in the world, every half a second, millisecond, a device is acquiring an IP address. That's how we communicate online. Your WhatsApp on your phone is communicating online via an IP address. Your TikTok on your phone is communicating online via an IP address. Your phone has an IP address. Your Apple Watch has an IP address. Your TV has an IP address. Your car has an IP address. Your microwave, your boiler, everything has an IP address. Your iRobot on your phone, your airport has an IP address. Every single thing has an IP address. As long as you're connected to the internet, you have an IP address. So if we don't connect the internet gateway to this VPC, we are not going to get the public IP. We're not going to get this IP address. This private IP address maps to this local route. Every communication going to the private IP will go to this local route. They call it local route. If it's any communication on the internet, will go from this IP address in your server through this route into the world, internet world. And anything coming from the public internet will go through this route to your public IP address to receive it on the internet, on your institute instance. So if you want to send a request to download some software from the internet, you're using your public IP address to go out to the internet through this route and download the software, and the response sent back to you goes through this route and saved on your device. So this public IP address is this institute instance means of communication to the internet. Now, someone will say, hey, but Thibault, if we already have public IP address, why do we need a private IP address? Well, your answer is here. Private IP addresses are used because servers, two institute instance servers, talk to each other through a private route. Servers talk to each other through a private route. So for a server to talk to another server, that means sending information within the same VPC, they use a private route. So they have to have a private IP to talk to a server that has a private IP. Public IPs are not used to talk to servers. No. Public IPs are meant to talk to the internet. For a server to talk to another server, he must have the same IP address range like him. That's how they're able to speak privately. Whenever you send information from one server to another server, no one else on the internet is supposed to find out. It's private because they have the first two numbers between them are the same. So the communication between servers are private. And you guessed it, TCP, UDP, what protocol do they use? TCP, right? They talk to each other over this private IP address to TCP. Any questions? Any questions, guys? Please ask, guys, ask. Is it clear or guys, please ask. It's clear, right? Is it clear how we acquire public IP addresses? Because of the internet, that's how I acquire public IP addresses. Okay, let's move forward. So a custom VPC, you can see if you use a 10.0.0/16 for your VPC, you can go ahead and you can create a 10/24 subnet. Again, guys, your subnet can be /20/21/22/23 or /24 or even /25. It doesn't matter. You can pick any subnet. Just know that when you pick a subnet of /21, it gives you this number of IPs. /22, this number of IPs. So based on your side of the application or your software that you want to create, you need to decide a subnet, right? The architects decide that for you, by the way. You don't have to decide it, but right? So /20 subnet, that's the number, /21 subnet. You can create a /24 if you want /24, if you want just 256 IPs, right? So if you want to do a little test, a little POC, a little proof of concept, you want to test some application, you don't want to really develop, you want to just test it to see if it's going to make sense for the company, you can go ahead and create a /24, which is small number of IPs, right? And then you can just test it. Or you can do a /25, which I would say don't go below /25. That's the lowest I will go, right? Okay. So a custom VPC, you can use you're going to do a 10.0.0/16. You create two subnets. You create a public subnet here, 10.0.0/24. And you create a VPN only subnet or private subnet here, 10.0.0/24. And you create servers in here. So this is the first IP, 10.0.0.5, 10.0.0.6, 10.0.0.7. You have three servers here, database servers. And then here you have a public subnet, right? Because it's your web servers. You have 1, 2, 3, so you have 10.0.0.5, 10.0.6, 10.0.0.7, private subnet as well. Sorry, yes, a private subnet as well. This is a private subnet as well. The private subnet, but once you add a VPN connection, so you add a virtual gateway instead of internet gateway, you add a VPN connection. You can connect from your on-premise servers from your office. You connect to VPN. You connect to the servers here. Do a VPN connection. Okay. The default VPC is great for launching new instances when you are testing AWS. But creating a custom VPC allows you to secure your resources. So this VPC here It's good when you're testing resources. You open into the internet, you're testing. But creating a custom VPC like this, connecting to the VPN from your office. So from your office location, this is your office, customer network. You can create a VPN connection, a customer gateway in your office, and you connect your VPN to your VPC. You don't need to create this VPC and everything, right? The network team will do it for you. When you go to the company, it's already created. You don't have to do anything. And because you want to create an application in the front end, your web server, and you want the IP address of this application to be fixed so that when you restart the servers, it doesn't disappear, you will create elastic IP addresses, elastic IP addresses, EIPs. So on the job, when you hear the word EIP, knows elastic IP address, they are fixed IPs. 198.51.100.1. They are fixed IPs. 198. These are fixed IPs. But these IPs are public IPs. Elastic IPs are public IPs. This is what allows people from out in there to connect to your application. Even if you restart your servers, the servers will come up and use the same IPs. These 10.0.0 are private IPs. See, same here, private IPs. They take the form of the subnet. They take the form of the subnet. Okay? If I'm going too fast, tell me now. I'll slow down, guys. I'll take a break. Do we take a break? These IPs right here are private IPs. They take the form of the subnet. This is the subnet. So this is private IP1, private IP2, private IP3. Same thing here.
Application develop. Why are they identical?
That is a good question. Why are they identical? Because they are in different subnets, they can be identical. They can be identical because they're in different subnets. This is a different subnet, and this is a different subnet. We have made this subnet private. It's private. There are no public IPs in this subnet. It's a VPN only subnet. So you connect to this subnet only to a VPN connection. You know what a VPN connection is, right? So VPN connection is when you create a tunnel like this. And so this is a customer gateway from your office, say in downtown Dallas. You use your IP address in your office, which is a 10.0.0/8, and it's a /8 here, and you're connecting to a VPC AWS, which is a /16, right? You create a VPN connection, you connect to these database servers here, and then this is your route, right? But these IP addresses here are private because they're in this subnet. They can be identical because they're in a different subnet entirely than this subnet. They don't clash, they don't conflict. But these IPs are public IPs that we buy and pay for because we don't want to take a random IP as you saw previously here. This is random. This is taken from the internet anytime. But no, we want to fix our application to have a permanent fixed IPs. So we do this. We buy elastic IPs. Okay. As time goes on, you understand more about VPC, right? I think I'm going too deep. I don't have to go this deep. Again, this is VPN, hardware VPN access. You're not going to configure VPN. Again, your SREs. This has nothing to do with you. It's just for knowledge. On the job description, you will see there's a part that says knowledge of networking, knowledge of VPN. So it's just for your knowledge. You don't have to implement it. You don't have to create VPN. It's just for your knowledge. You just need to know how things work, right? Don't mind me. I love it so much. I can go deep and deep and deep, but just take it with a grain of salt. This particular VPN piece, take it with a grain of salt. All you really need to know in VPC, and I said in the very beginning, is just your subnet and the VPC. That's all you need to know in VPC. That's it. That's why I'm not going to teach all of this slide. The only thing you need to know VPC is the VPC and the subnets and how the IP addresses are generated. So that when you see an IP address, you're not surprised, oh, where did it come from? Because there were a time when you go create an EC2 instance in the VPC that you don't know if it's public or not. So that the VPC was private, but the VPC is public. So you go create a server in that VPC, and then you see a public IP address attached to the EC2 instance, like this. And you're like, hey, where did this come from? If you see a public IP address that doesn't resemble the subnet, know that that IP address is public. And now that EC2 instance is public. Do not put any customer data on the public server. Do not put any customer data on the public server. Customer data must always be in a private server, like here, private server like this, VPN only subnet. Do not put customer information on a public subnet. Never, never, never. That's the easiest way to get fired. So when I ask you, how do you secure customer information? You say you put it in a private subnet. That means you make sure that there's no internet gateway attached to that VPC at all. At all. Some companies don't even use internet gateways. They don't even create it at all. They don't want to have a chance that something exposes in it and they have a data breach, right? So hardware VPN connects your VPCs to your existing data center using the hardware VPN access. So you can extend your data center into the cloud and create a hybrid environment. You'll hear about hybrid cloud. Some companies still do hybrid cloud like Geico. That means that they move to the cloud, but they still have their on-premise environment. So they have offices in Los Angeles, Chicago, New York, Miami. They have big offices in those locations, like huge offices and data centers. And then using a VPN connection, they connect to the AWS VPC. So Tolu, in these locations, where's my pen?
Yeah.
They have what? They're using better 10.0.0/8. That's what they're using here. So /8 maps into a /16 in the cloud. So customers will sit here, and people that work for Geico will sit here and through VPN, they'll connect. Let me show what VPN is. I have a NordVPN right here. Where is my NordVPN? That's it. So I can sit here and I can connect. Let me remind me later. I can sit here and I can connect. From here, I can connect to, like, I don't know, Lithuania and pick a server. Connect to Stockholm. And I connect to here. I'm connected. Now when I go to Google and I search anything online, and they just say Friday, it should come up in like a Swedish. Look at that. Hello? You guys see my location should show Swedish. Right here. Stockholm County. Sweden. They speak English over there. If I connect to France or Paris, finding the best server to connect in Paris. Connecting to Paris, connected. I refresh my browser. Show me in French. Assurez votre logement. See, it's in French. And you see my location, it's Ile-de-France. So that's what a VPN connection looks like, right? You're connecting from Los Angeles, you connect your VPN to AWS, and from Los Angeles, it will be as if you are in US East 1, but you're physically located in Los Angeles. Same thing for all these other locations. Okay? Cool. VPC pairing. Sometimes companies want to isolate applications. When I ask you in an interview, how do you isolate your application? Let me go to the board and explain this. This is important. application isolation. You have the marketing department running their application in VPC-A. They have their EC2, everything running in VPC-A. You have the finance department running the application in, let me just put it in here. They're running in VPC-A. Note this line. VPC-B. And you have human resources department running the application in VPC-C. Okay, let me remove these lines. So all of them are running the application separately. Okay, separately. But human resources need to make payroll. So human resources need to collect information from finance to payroll, right? So they have the application here running. The application is called Workday. Finance is running the application called Salesforce, or what's the application called? Salesforce, or what's it called? Yeah, Salesforce. So they need to be able to collect money from these people and make payments. So how do these two applications talk to each other to create payment of employees? They have to PA the VPCs. So you do connect this VPC like this, and here you call it VPC peering. VPC peering is joining two VPCs so that communication can flow from this VPC to this VPC and back like this. So they join two VPCs, they can talk to each other like this. So this VPC is in its own account here. This is HR account, AWS account, separate account entirely. And this finance application is in its own account, finance account, entirely. And then you have marketing account. They have their own AWS account. So these are three AWS accounts, separate accounts. So HR needs information from VPC to do the payroll reports, right? So they're gonna connect here, and finance information will send reports or send information, and they can, back and forth like that. Marketing department needs money to run marketing campaigns. So guess what? You go and pair VPC-A, VPC-B, VPC peering. So now finance will give money like this to the marketing department to run marketing campaigns. And marketing campaigns will also give marketing department will also return the receipt back to finance department. So the two applications talk to each other. You have Facebook marketplace, you have Salesforce. So whatever happens in Facebook marketplace, they need to report it in Salesforce. Whenever Salesforce give money to Facebook marketplace, they need to record it here. So they talk to each other. Now, someone will say, Dibo, what if marketing application wants to talk to human resources? Does it go through finance VPC to talk to here? No. That is called transitive peering. Transitive peering. There is no transitive peering allowed. No transitive peering is allowed. No, that means that marketing wants to talk to VPC-C, VPC-A wants to talk to VPC-C, it wants to go to VPC-B to talk to, no, that's not allowed. If VPC-A wants to talk to VPC-C, it has to go pair direct, like that. VPC peering. And the connection has to be bi-directional. It has to be bi-directional, meaning that bi-directional. Directional, directional, bi-directional. Bi means two. 1, 2. Bi-directional, bi-directional, bi-directional. This is a typical company that has 3 VPCs, 3 accounts, 3 departments. Just look at it. VPC peering, a peering connection allows you to route traffic between 2 VPCs using the private IP addresses. So EC2 instances in their Ethernet network can communicate directly with each other. So this application in here running on EC2 is running on an EC2 instance that has a private IP address. This application running on an EC2 instance that has a private IP address. So when they want to talk to each other, they use what? The private IP address. Same thing here, same thing here. As you know, servers talk to each other using a private IP address. Servers talk to each other using a private IP address. Servers talk to each other using a private IP address. Okay? Any questions so far?
So is it sufficient to say that the major function of a private IP address is to communicate to the other servers? That's
Yes.
the fundamental function.
Yes, that's it. That's it. It's for communication. IP address is meant for communication. Yeah, period. Right? If you want to go on the internet, you need an IP address. But if you're on the internet, it's a public IP address. If it's between servers, it's a private IP address. Human beings cannot use private IP addresses. Only machines use private IP addresses. Human beings cannot use private IP addresses. Only machines, servers, can use a private IP address. I love networking, guys. So you can see here, VPC B can talk to VPC A, right? VPC C can talk to VPC. VPC A can talk to VPC C, right? The VPC A cannot talk to VPC C through VPC B. No transitive pairing. Okay? So no transitive pairing. If VPC B is already connected to VPC A, and VPC A is connected to VPC C, VPC C cannot connect to VPC B. This is not allowed. Because it's going to be a round robin. This is not allowed. So let's go back here. This is not allowed. I misspoke. Sorry. There we go again. Right? Correct myself. So this is not allowed. This is if you create this, it's going to be transitive pairing. If marketing is talking to finance and this talking to finance, that's it. This guy cannot talk to each other. No, they cannot. So no transitive pairing is allowed.
Why?
Because if it happens like this, then information can leave here, and go here and go there. That is not supposed to happen, right? For security reasons, right? It's like, let me put it this way. Me and Kwasi are having a conversation. This is Kwasi, VPC. Kwasi is VPC A, Debo VPC B. We're having a conversation. Okay. Kwasi go decides to have a conversation as well with Isabel. Isabel is VPC C. And then Isabel decides to have a conversation with me. What is this called? Gossiping. Right?
So what if we limit the conversation like
You cannot
to
limit
the
it because if
we can we
once you open the route, sorry, once you open the route, everything that Kwasi has told you, you can tell me. Kwasi can control what he shares. I can control what I share with Kwasi. It's a one-to-one relationship here. Kwasi can control what he shares with you. You can control what you share with me. But if I have a connection with you, then this guy is not in the loop. And then so we're taking whatever he shares. So we'll end up having more information than this guy. And so the security risk is that because we want to isolate application, let me go back to my board. We want to isolate finance application. Finance is the one that is paying us human resources and it's also giving money into the marketing department, right? Finance is the leader here. Is the main person disbursing the money. We don't want to go behind finance back to talk to human resources. If we need some information from finance that has to do with human resources can send an information here and finance can share it here. But we don't want these two like this. It creates a round robin of information leaving here, going, and then going back to here. It's deeper than that, Isabel. Honestly speaking, it's deeper than that. But all I know is that no transit pairing is allowed because you already have a connection between A and B. When you try to connect A to C, it will complain that, hold on, you already have an existing connection to VPC B. I'm sorry, I cannot connect to you. Also, VPCs are only allowed to connect to one VPC at a time. So VPC C will say, oh, I'm already connected to VPC B. I'm sorry, I can see that you're connected to VPC B. I'm sorry, I cannot connect to you. Because of the bandwidth restrictions and network and IP addresses restrictions, you cannot connect one VPC to two VPCs at the same time. So no transitive pairing is allowed.
Okay, so how does some company do to have, because I know that sometimes in marketing you can have access to some data from human resource and access to some data at finance and even logistic. Like how do they do that to interact?
They'll put the data in one place. That's a good question. I'm happy you asked that question. They'll put it all in one place. They'll put it in finance account and then give access to marketing and they'll all get it from here. Does that make sense?
Okay.
If marketing wants some human resource information, it will request it. He will make a phone call. Hey, I want some human resource information. Well, we don't have a connection to you. We're going to put it in the finance account in a folder called human resources, like a SharePoint folder. They'll put it in that folder and then marketing will go and access it. That's how it's done. Okay, Chris said, thank you for asking that, Isabel. So yes, there's another thing called, this is a big issue, right? Companies complain about that. What Isabel's complaining, and this is a solution that Amazon created recently called Transit Gateway. It's expensive, but it's a solution that solves this. Transit Gateway solves this problem. Where's the architecture? Transit Gateway solves the problem. Let me go back. Transit Gateway, kind of image here. Open this image. Open. I didn't mean to do that. Accept. Is it clear? Okay, it's clear. Can you guys see this image? Let me zoom it out. Make it more larger.
Yeah.
Yes.
You can see you have a VPC here. You have another VPC here. You have another VPC here. So Amazon's like, okay, since you guys want to come in and you want to talk to this VPC, want to talk to that one, I'm going to create a transit gateway That means something in the middle. You can have 100 VPCs. VPC A wants to talk to VPC B up here. It has to go through me. It's a hub and spoke model. If you know a bicycle is a hub. A bicycle has a hub and spoke. So if you have VPC A, B, C, let me just draw it in the board. I think that's better. Let me just use my board and draw transit gateway. It should be faster and easier. So I'm going to take a round diagram right here. Boom. This is the transit gateway. So no VPC, no transit peering, but they created a transit gateway so that people can do their transit since you guys want to transit. Literally, right? So boom, there you go. You have your marketing, you have your human resources, or you have HR, which is VPC B. Was it C? C, right? Let me go back here. Then you have finance. And let me add one more. Let me add how do they call this company that drills oil? Department. Operations. Field operation. Let's say it's an oil company. They have field operations. So the drill company, because I work for Shell Oil and Gas back in 2008. So they drill oil. So VPC D. Right? So this is human resources. This is VPC A. So if marketing wants to talk to field operations, it sends its traffic to the transit gateway, and transit gateway will point to here. Like that. Boom. Finance want to talk to HR, it hits transit gateway, and transit gateway will talk to HR. So you send your traffic request, it goes to here, the request comes here, response goes back to the gateway and comes here. Marketing want to talk to finance, instead of a VPC peering, no, since you're already connected to that gateway, it goes from here to here. Like that. And that solves the problem. But what's the problem? What's the issue? Customers are complaining that this is expensive because Amazon charges what? The transit gateway pricing. It's expensive. Amazon is charging for every gigabyte that goes to that where is it? Price per, let's do US one. Price per AWS transit gateway attachment. 5 cents per attachment. Price per gigabyte data processed. 0.2 cents. It has even gone down. It used to be like 50 cents, something like that. So for every gigabyte that goes through, this is 0.02 cents. If you have 4 VPCs, that's 4 times 0.05 per region, per account, just for the attachment. And then the data that goes through, 0.02 cents per gigabyte. So if you have 2 million gigabytes, 2 million times this is $20,000 for traffic going to the gateway. But VPC peering, since it's within the VPC and it's within your account, there's no charge for data leaving this VPC to this VPC. If it's within the same account, there's no charge. There's no charge for this. No charge. It's free communication. But this, there's charge for the attachment and for all data going through. Like that. Does that answer the question? Yes?
Yeah. Yes.
Okay, cool. I'm glad. Okay, cool. We're almost at time. I wanted us to do Terraform today, but I guess we're going. So VPC, default VPC, do not delete your default VPC. Do not delete your default VPC. Please. Delete your default VPC, you have deleted your account because you have to contact AWS to restore it because Amazon uses your default VPC to control your account. So custom VPC. So what is attached to the default VPC? What is attached to the default VPC?
uh, internet gateway, options.
You already said it, man. It's you. That's who you are, man. Internet gateway. Why would you create a custom VPC?
Option A.
Okay.
Hey,
IP address. Private IP addresses is not reachable over the internet. There we go. Very easy. Guys, I think the reason is because I'm teaching the things before we even get to the PowerPoint, right? We actually go to the PowerPoint, right? Let me just connect this VPN here. I'll disconnect. Is Kobe here? Oh, look at that. Kobe made it. Hello, Kobe. Welcome. All right, private IP addresses are not reachable over the internet. That's what are private. That's it. Simple. It is used for communication between instances in the same network. It is used for communication between instances or servers in the same network. When you launch a new instance, it's given a private IP address and an internal DNS hostname that resolves to the private IP address of the instance. A private IP address maps to the internal DNS, domain name system hostname. Okay, it's that simple. So private IP addresses, that's a private IP, that's a private IP. They talk to each other over that private IP. They cannot go to the internet, they cannot. It's private. That's what makes it private. Once you add internet gateway to that VPC, they're no longer private anymore. Okay? Public IP address is reachable from the internet. You can use public IP addresses for communication between your instance and the internet. That's it. Because the internet is based on your zip code or based on your location, your public IP address will not take the form of the subnet. It takes the form of the location where you are. So if you're in Virginia, you might have a different IP than somebody who is in Texas because of the location. That's it. Elastic IP address is a static IP that is public. It is static, meaning it doesn't change. It's static, but it's public. Persistent public IP, meaning that if you attach it to your EC2 instance and restart your EC2 instance, it will come up and stay the same. Any questions?
Please, can you repeat this part because you say
An elastic IP. Elastic IP is a static IP. That means it is fixed. If you create an elastic IP and you attach it to your EC2 instance and you restart your EC2 instance, the instance will come up with the same IP address. On a normal EC2 instance, when you create a normal EC2 instance, it comes with a private IP by default. If you create an EC2 instance in a VPC that is public, that has an internet gateway attached to the VPC, that EC2 instance will have a public IP address. That public IP address is not static. It's not fixed. Whenever you restart your EC2 instance, it will come up with a different IP address every time. Because as you know, when you create EC2 instances, they are being created in different hosts or different availability zone. So it will come up with a different IP address every time you restart it based off of the internet. It takes the IP. Whenever you turn off your IP at your EC2 instance, you lose your public IP. When you turn it back on, it comes on, and when it connects to the internet, it acquires a new IP address. Let me show you this. If I do this, what's my IPv4? It shows me this, right? That's my IP, right? 72.190.22.10. If I restart my laptop, I turn it off and turn it back on, it will show me a different number. Because by the time I come back on, this IP has been given to somebody else. So I might have like a 72.190.13 or something. Same thing with EC2 instance. When you restart it, it comes back with a different IP. But because we want our application to have a fixed IP address, because we have given our licenses to customers, we have customers that know that this is the application. We want to bind our IP addresses that is fixed to our application so that our customers come back to the same thing they left the same way. When you add stuff in your Amazon cart and you go and spend 2 years, you come back and it's not there, would you be upset? Kwasi, I'm asking you, would you be upset?
No.
Yes, you should be upset. If you have things in your cart, in your Amazon cart, when you're online, when you're shopping, and you come back and not, you should be upset. Binding a fixed IP address to Amazon.com is what enables when you come back to Amazon, you look in your cart and everything you added is still there because it's static. It's public, but it's static. It's permanent. Even though the Amazon.com EC2 instance will restart, it will come back with the same IP address every time. So an elastic IP is a static IP that is public, but it is persistent through server restarts. It's persistent. It's allocated to your account and can be associated to an EC2 instance as required. In this particular case, we have attached 74.85.2.2 to this EC2 instance. If we restart it and bring it back up, it will still be there. Okay? It will still be there. Any questions? I like the questions coming. Keep them coming. I think we're understanding VPC at the basic level. That's all you need. You don't have to be an expert at this. I'm okay with just the basics. It's fine. I think you guys got it. Any questions, guys? Let me demonstrate how to create elastic IP addresses. When it's an elastic IP address released from your account, you cannot answer this unless you can demonstrate it first. Let me go to the AWS. I go to elastic IPs. I'm going to create an elastic IP. So Amazon pool of IPv4 addresses, public 5 addresses, US is 1, allocate. Boom. It allocates an IP address. That's it. So I need to take this IP address now. I can go to actions. And that's it. I want to associate this IP address. Associate the IP address. I don't have an EC2 instance, so I attach it to. Let me create an EC2 instance. See, elastic IP is 1. Launch an instance. elastic IP demo. Just leave it the way it is. My key pair, I'm not going to connect to it. Select security group that I've already used before. Default. Launch. And that's it. Now I can go back to VPC. Elastic IPs. Select the IP address and associate. Sorry, I already allocated it. Sorry. Go click here. Actions. Associate it with an EC2 instance. Attach it to that EC2 instance. So we go back now to EC2 and look at the IP address for this EC2 instance. That's it. It came up with a different IP address, but because we attached that elastic IP, that's the public IP for that EC2 instance going forward. This is a private IP address because we created in this subnet 172. The subnet here was what? The subnet in this, from this private IP address, you can tell the subnet, right? You can tell the subnet, you can say the subnet was what? 172.31.17.0/ We don't know what the slash is because we cannot tell how large the subnet is. But you see, this is the private IP address that we're giving. This is the public DNS. This is the private DNS for the IPv4. And that's it. So now, if we restart this instance, reboot, it will come up and come back with the same IP address. It's rebooting. You come out with the same IP address. Okay? But whereas if you do not attach an elastic IP address and you reboot it, it will come back with a different IP address every time. Okay? So we allocated an elastic IP address. We associated the IP address with an EC2 instance. And now if we want to delete the elastic IP, we'll go to elastic IPs. And the first thing we have to do, if you look here, we have to disassociate the IP address. If you try to release it, it means delete it, release, it will fail. Cannot be released because it's attached to an instance right now. So you have to first of all come here and disassociate the elastic IP from the EC2 instance. Then you release the elastic IP. And that's it. So the steps are you allocate, then you associate to an EC2 instance. Then we don't need any more. You disassociate, then you release. 4 steps. Allocate, associate. When you want to delete, you release. Sorry, you disassociate, then you release. When is an elastic IP address released from your account?
Option C.
It remains in your account and you choose to release it. That's it. So we'll come back on Monday. We can look at subnet. Before we go, I want to just show you how to create a VPC really, really quick. You don't have to do anything on your end. I really want to introduce Terraform today. So please just bear with me really, really quickly. I'm going to open a folder here. I'm going to create a new folder. I'm going to just call this folder cancel. Put it in documents. Call it VPC. And I'm going to open this folder. So in Terraform, to create a VPC, just an empty VPC, this is the code. VPC.tf. TF stands for Terraform. And I'm going to write resource AWS underscore VPC, right? And then the VPC name that I want to give, just say dev dash VPC, bracket open, cider. You see, I have this extension. We're going to install this extension now before you guys go. An extension that I installed that it auto-completes. So guys, back in the day, we didn't have this. You have to copy from the internet, all right? But nowadays, we have ChatGPT, Copilot, all these things. So when you're typing, it will give you suggestions, and you can just hit enter. So now cider block equal to 10, or let's do 192.168.0.0/16. And that's it. That's it. We can put another one option like enable DNS host names equals to true. And that's it. That's it to create VPC. We'll save that file. Save. Then here now, in the new file, this is the configuration to connect to AWS, provider.tf. So I'm going to say provider. Provider is AWS. Region is US-East-1. And that's it. Save the file. That's it. Save the file. That's it. Now to run this code, all I have to do is open up a new terminal. Make sure that I'm in the location VPC. Well, I want to use Z shell. I like Z shell better than my screen. Make sure I'm in the same location. Linux, ls-ltr. I have my 2 files in there. And now I want to configure connection to AWS. Share my screen. So what do? I type AWS configure. I need to put access keys and secret access key and my region name and its default output. So I'm going to go to the console, go to IAM. I'm going to create a user. Create a user and call the user debo-terraform-user. Do not provide access to the management console. Whenever you're creating a user that will be doing things programmatically, do not provide access to the console. It's optional. I'm going to do next. Attach policies directly. And then check the box. Administrator access. That's it. You click next. Create user. And that's it. You have created a user. Now, to get those access keys, you click into the user here. You go to security credentials. You create an access key. You choose command line interface. Command line interface. Command line interface. Select that box. Choose I understand. They are both recommendation and I want to proceed to create my keys anyways. Create access key. And that's the key. I'm going to copy this key. Right click, copy. Go now to my VS Code. Type AWS space configure. Paste my key. Enter. Copy my secret key. I don't want to show it because this thing is recording. I can still show it. I'm going to delete it anyways after this. Copy this key. Or you can highlight it and copy it and paste it in there. US-east-1. You already have the region in here, right? You may not have to put it here, but I just put it there just to show you that you can either put a region here or leave it here. Either one is fine, but I prefer this one over this one. Clear screen. Okay. And now all you have to do is run the Terraform code. You can close all that stuff. And the first command you want to run is Terraform init, means initialize. This command downloads the Terraform plugin, binaries in the whole Terraform software and set it up. Initializes the Terraform plugins. Little version for HashiCorp AWS is using this version for AWS 5.84.0. Installing it right now. Come on. My internet is slow. You can see from here. I'm in my office, not in the living room. Come on. Slow. On. Internet is slow. There you go. And it's done. It's done. Next command you want to run, Terraform format, FMT. This will fix your code. If your code is not organized, like from here to here, it's 4 spaces. 1, 2, 3, 4. Let's say you don't have enough, there's not a space. Let's say you have it like that. Like running Terraform format, it will format those files for you. It organizes it so it's 2 spaces, not 4, right? It fixed the code for you. That's what format does. It formats it correctly. Then now the next command to run is Terraform validate. This command validates your code to see if your code is correct syntactically, if your code is correct syntactically, and if it's you're using the right syntax, like your double quotes, your dashes, all these things is correct, right? Validate. When it validate, and it will check it, success. Configuration is valid. Now let's go to AWS and make sure that we don't have a VPC already there with that name. So I'm gonna go here. If you look at all VPCs, I already have 4 VPCs. I have this dev DBX VPC here. So I have 1, 2, 3, 4. So I can only create one more. But I don't have a VPC that starts with 192.168. So I'm going to create a VPC that has 192.168 CIDR block range. Okay. So with that being said, if you look here, we don't have a VPC. So it's going to appear here. How does Terraform connect to AWS? Using those keys we just put in. Those keys we put in, right? That's how it connects to AWS. It connects programmatically to the back end. So this is your client. VS Code is the client. And when we send the command Terraform apply to the AWS server to create a VPC on our behalf. So Terraform is going to create a VPC for us. So the next command to run is Terraform plan. This Terraform plan will show us the plan of what it's going to do. It's going to show us a plan. Here, Terraform connects to the AWS for the first time and show us the plan of what it will do. So Terraform will perform the following actions. It will create a VPC called dev-VPC for us. It will use user block, and it will create DNS hostnames equals to true. Everything else will be default. Everything else we will know after it's done creating. We're going to find out after it's done. The plan is to add one resource. If you want to delete it, when you read Terraform destroy, it will show one to destroy. If you want to change something, it will show one to change. So in this particular case, we want to create one VPC. So it's only one resource. So the next command we're going to run is Terraform apply. It's going to ask us a confirmation. Do you want to perform these actions? Terraform will perform these actions described above. Only yes will be accepted to approve. If you say no, it will not create it. If you say yes, it will go ahead and create a VPC, creating VPC. And that's it. This is how resources are created on the job today. One resource created, and that's the VPC ID. That's it. F16, that's the number. If you go here, you refresh this, that's your VPC. That's it. Welcome to DevOps. I'm officially welcoming you guys to DevOps now. That's it. Now, in this VPC, if you open it up, you see enable DNS is true, default host names is enabled. Let's say I want to go make this to false. DNS host, I want to change to false. I can go in here and say, I don't want to make it to true anymore. You see, it was true here. So if you go here, it's enabled. I want to make this, I want to disable it. So I can just go here and change this code to false. And I'll save it. When I save it, the first thing I run a Terraform plan. And you see, it will show us the changes, how it's going from the old to the new. Terraform perform the following actions. It will change DNS host names from true to false in the same VPC. One to change. Now I'll just type on Terraform, apply, and it will apply the changes. Yes, apply the change, modifying the VPC, and making the change. And that's it, one change. Go to the console, you refresh it. You have to refresh it, right? Let's refresh. Disabled. That's it. It's disabled. Now, to delete this VPC, all we have to do is come here and type Terraform destroy. And it will show you that it's going to destroy one resource. See? One to destroy. You want to destroy it? Yes. And it's destroying the VPC. If you go here, you look at it, it's still there. But once you refresh it, it's gone. And that is Terraform Basic. Any questions? That's it. We're done. Your code still remains. Everything still remains. But the resources are gone. Now the question is, how does AWS know that we had this in false and changed to true? The brain behind all of this is called a stage file. The stage file. This is where all the information in the console for that resource is stored. The state file right here. It has everything stored here. So if you make a mistake and you want to go back to what you used to have, you come to the state file and you use the state file to recreate the resource. You see, everything is in there. We have deleted the VPC, right? VPC is gone, right? It's been deleted. But we'll still have the VPC ID and everything in here is saved. So this is a backup file. Backup. So whenever you delete something by mistake or make a mistake, you can come here and use this file and recreate what you had before. That's it, guys. That's Terraform 101. We'll do more creation. We'll create EC2, we'll create S3, we'll create IAM. Everything we've learned in AWS, we're going to create with Terraform. But it's very, very easy. All the code is found here. Terraform.io. All the code is found here. Terraform, AWS documentation. Yeah, that's it. If you just come here and look for EC2, you see EC2 right here. What is it? EC2 resources. That's EBS. EC2 instances. EC2 instance. That's it. Create an EC2 instance. That's it. Simple as that. You come in here, create a new file called ec2.tf. Paste that code in there. You call this code. The name of the EC2, you want to call it, dev-ec2. You want to use an AMI. You have to copy the AMI from AWS. So in this case, you go to EC2, you copy the AMI ID. This is the AMI ID in here. Oh, how do I copy this time around? They don't make it easy for us to copy. Huh? Kwasi, can you copy this AMI and send it to me in the chat, please? AMI dash 0DF8C184.
Go slowly. Let me start over again, please.
AMI dash 0 D as in Debo, F as in Foxtrot, 8 C as in Charlie, 184 D as in Debo, 5 F 6 A as in Apple, E as in Echo, 949. AMI dash 0. Okay, thank you. Boom. You copy that AMI. I will show you guys a different way that you don't have to copy. This is the basic way, right? Show you guys the basics. Basic steps. AMI is required. Instance type, T2 micro is required, and that's it. You close the bracket. Open bracket, close bracket. You must have your open and close bracket. That's it. Save it. Done. Now, if you want to create it, you do Terraform, apply, because you have, Terraform init, because you have a new resource, you want to initialize so that this resource would enter the state file, okay? Terraform format, Terraform validate, okay? Terraform plan will show you that you're going to create 2 resources now. You see? Now it's showing you two resources. It's going to create a VPC and it's going to create an EC2 instance. Showing you right here. Now you do Terraform. Apply. Oh, spelling error. Terraform. Apply. And that's it. Yes. Um, the AMI is not correct, Kwasi. You made a mistake. The AMI is not correct. Are you sure you gave me the right thing?
I was just copying what you were saying.
Yeah, I know. Um, AMI dash 0D F8C 184 D5 F6 AE 949. Yes, incorrect. So yeah, we missed some numbers here. Okay. And then save it. Terraform plan. The thing with Terraform is that if it's supposed to create two resources, if one fail, it will create the other one. So it already created a VPC already for us. We go to VPC. VPC has already been created because VPC code is fine. So VPC has already been created. That's the VPC there. That's it, right? Disabled, right? Because host names is disabled, right? So now we're gonna run the EC2 instance creation. Terraform, apply. Yes. Uh oh, you have requested more vCPU than your current account. Oh, limit of one. Okay. Yeah, I have an EC2 instance running already, so I can create more EC2 instances. Yeah, I have this one running already. So I'll delete this one. You see that when we visit IP, it changed IP change, right? So let me delete this one. Okay. And then apply again. Apply dash auto dash approve. Well, I don't want to type yes, I want to just run it. So I just want to type there apply space dash auto dash approve. And you should just run it. Hopefully it works. I think it's a issue with my account. Okay, now it's creating it. Oh, yeah. I have exceeded my limit for the month, I think, to request an adjustment to this limit. Yeah. Let me wait for this to terminate and try one more time. Because it's a free tier account, this should not be an issue. Yeah. Okay. I'll resolve my account issues and we'll do it again, okay? I've exceeded my limits for the month, I think. So I'll resolve this issue. But that's it. Any questions?